All right, welcome to this video, and I want to welcome you to the channel. And if this is your first time to the channel, please remember to press the subscribe button for more content like this. Many things are coming along your way, so just stay to the channel and subscribe for more interesting stuff. Today we are going to sort of review what we looked at in the previous series about generic functions and structs. We sort of doing a review, but of course there are some new things that are going to be coming along. We are going to be reviewing generic functions. Why do we need generic functions? Sometimes you have functions and you probably want maybe a square root of maybe an integer where you want to have the return, maybe the value to be an int 64, okay? And at the end of the day, what you want to do is you want to define a value inside here, and that value could be maybe a, where your a should be understandably an integer 64. So what do we do at the end of the day? We want to get a and compute the square root of a. But what if we want this same function for maybe a float? I don't think we have an integer 64, but we have a float 64. We can say this is i32. Yes, in order to be consistent. It means if this is to be like it is your need. If this is your need, it means you're going to duplicate these functions. But what if you can write a single function that can compute the square root for all type parameters or return types that you want? For floats, integers, int, anything that you want. So we can do that using or leveraging templates. And by leveraging templates, we can write generic functions. So how can we write a generic square root function, for example? So we can say function declaration signature square root, and we want to pass these angle brackets to pass the type parameter or the template, so to say. So here we will have x, and x is that value they want to compute for, but because we don't know the type, so we pass the template type. And at the end of the day, of course, we want to return template result. So this could be an integer, a float, and that's where the power of templates comes in, by writing generic, enabling us to write generic functions. But there is something we want to do from here, and this is something that is called trait bounds. And when you look at the standard library for Rust, this is where these traits have been implemented to help us write more robust generic functions. So we have this keyword where at the end of the day, what you want to do is to write template, and that template is being defined as into, and what this means. Okay, let us first write. But what this means is we want to make sure we want to handle template that has been given, which is template type parameter, that at all times the value of x is going to be able to be passed into the square root function, and the into helps the function to be able to handle the floating 64 value. So that's what that trait is. If you don't know what a trait is, we've talked about traits on this channel, so you can review earlier videos, and which I will link in the corner there. Then we have another trait or a bound called from, and this is also from float 64. And the from means at the end the result will be passed out, and that result will be passed out as a float 64. So that is something that has to be part of that generic function. So we now want to define the function body, and the T is scoped. This is the namespace, or if you are from C++, called the scope resolution operator. And this is from x.into. Take note of the change in this is square root.sqrt, the note of the cases in into. So that's something that we have defined as a generic function. And for us, in order to test it, we come to the main function, and we can say that we can let the root equal to square root of any value that we want, that we know, maybe 84, okay? And we want to print the result, of course, and we want to print root, okay? So we come here, we say cargo build. This project was set up with cargo, and I hope you guys know how to do that. And we are getting an error, and we are getting this required by this inbound square root. Okay, what does that mean? I want to take you guys through some of these errors such that we understand what is going on. So we run cargo build and we are seeing that required by this bound in square root. And what does this mean? Maybe we can look at the error. It is detailed. Okay, we need to do that. The string literal there for printing, but also the trait from F64 is not implemented for integer. This is what I wanted mainly, this. So we can do this with the print formatters. That's okay. But what we are saying is that we are looking at this as the definition for F's for floating point values, specifically F64, not for integers. Meaning our square root has to be an integer, not has to be a floating value, sorry, not an integer. So by making it a float, we expect at least here to get something. So if we run cargo build, yes, our program builds successfully, and if we run cargo run, we are getting that square root. Now, what if we wanted an integer? That means your value should be a U32 and maybe, sorry, not a U, an int 32, so integer 32 bit size. So this means this should be A34. This is not going to compile for some reasons, and let's see why. If you build, yes, it's not building. Why? Because the square root is the square root found for type I32 in the current scope. There is a method isqrt with a similar name. So they are telling us that we can't use the beauty with the Rust compiler, that it will tell you, even make suggestions for you when things don't run smoothly. So in order to do this, we just need to call the I square root, and running this again, cargo build successfully, and the cargo run, we get 9, just like we expected. So that's the most about generic functions. You'll probably pretty much have similar behavior. There are other behaviors we can talk about. For example, you could have things like a divide function where you want to look at the numerator, okay, and maybe the numerator is F64, and the denominator is an F64 also. Now, this extends to what I talked about initially about generic structs and generic functions, but specifically we want to talk about structs. So we have this result struct that is defined in the standard library of Rust, whereby maybe you want to find the result as an F64 and maybe a message out as a string, and you define the function body where you perhaps say if the denominator is 0, you want to say something, and that could be an error. All this error is coming from the result enum, sorry, struct that is defined within the standard library, and you want to perform format and with an exclamation and print out this message or put out this message that you are dividing by 0. Okay, then you want to have an else part of this, and you say everything is okay when this happens. So that means you want to have the numerator divided by the denominator. This is another intuitive way of using generics, where you have this standard library result function. If we could hover and see the comment from the standard library, like result is a type that represents either success or failure, and when you look at the documentation, it is purely represented as a generic struct in a sense like this. Result be represented with T and E. So the template and E, where T represents the possible template, solid type parameter that can be put out, and E is representing the error. That's another way of using structs as generics, and we have looked at them even on this channel. You can go back, watch some videos about them. Another way that I might find interesting of using generics, perhaps even in functions, if you have a function like maybe swap, but this time swap could take 2 type parameters, type 1 and type 2, and what you want is you want to perform some sort of swap. So you have value A, you want to swap it with value maybe B. So B is type 2, and what do we want in that to return is type 2 takes up the first position and type 1 takes up the second position. And the function body is that easy in that case, where you just have B and A, and that's all. So if you want to call out that function, you would have something like maybe swap swipe equals to the swap call where you want to swap 3 and 4, and you want to print on the line I'm looking for, yes, this is what I'm looking for. Okay, so I'm looking for these they're called the debug formatter specifiers, and this is yeah, so we define one there because we have 2 values. We define the other one there. Okay, so we want to swap, actually I don't need 2, I need 1, I need swap. So if we try to build, why is that? No, that's not, sorry about that. I think it should be swap. Denominator 0, why did we do that? 0.0, okay, yeah, because it's a float. Okay, that runs, and now we want to run. Yeah, so we have 4 and 3, and they are swapped. So that's one of the ways we can use, or those are some of the ways we can use the swap, sorry, the generic templating, or using templates in order to write generic functions. And you can see it is powerful. It can be extended when we start writing big projects like applications. You will see maybe managing API errors and maybe writing custom errors in a given function. You want to control user behavior. You'll see that these turn out to be very powerful functions. That's all I had for you guys. See you in the next video. Bye bye.